Yeah, that wasn't supposed to happen. I spent a month building this 3.3 rocket for under $100, but before the launch, 3 things could completely destroy it. The first problem is the parachute deployment, and if this fails, the rocket will hit the ground at over 100 km per hour. In the first video about this rocket, I solved this with a small charge that activates after 4 motors burn out. The problem is, this charge is normally activated by the motors, which get really hot when burning. And since the booster is made of plastic, testing it would destroy it. So how do you fire the charge without actually firing the motors? This is a fuse, and if it can fire a firework, why not a rocket separation charge? So I tried it. And the booster separated from the main body really well. Maybe too well. Then I just made another one, cut the fuse to touch the tip of the motor and glued it to the booster. The second problem is my flight computer. Somehow after it was working and I went to test it one last time, I thought it didn't work. And after 2 hours of troubleshooting, I finally found the problem. The voltage was too high. And yeah, that would have been a really easy fix if I hadn't taken it apart like 5 times because I thought the problem was something else. But anyway, after it finally worked, even after 10 tests, it was a huge relief to put it inside the rocket and realize it fits perfectly. But how do you actually launch the rocket? I can't just use a fuse because we need all 4 motors to ignite at exactly the same time. Otherwise, it could lead to twisting and crashing the rocket. So we needed another solution. I built this remotely controlled launcher powered by a car battery. Time to test it. Nothing happened. I pressed A again and nothing. After pressing it like 20 times, I finally realized something probably isn't working. But I still need to test the igniter on my motors, so I had to connect it manually, if you know what I mean. And just to be clear, don't do this. It's a terrible idea. Anyway, the igniters work, but I still needed to solve the problem with the device. And it turned out that when your module is ready for switching 5 amps and you decide to test it with a car battery, you won't switch the current. The current will switch you. But what if you don't need a car battery in the first place? So I designed a new, better device with 4 different channels instead of just one, and with a small LiPo instead of a 10 kg car battery. Anyway, after that I tested it one last time before launch and it worked perfectly. Which is great because I built this for only 12 euros and buying one would cost over 40. But even though we can now launch the rocket remotely, what will we launch it from? You can't just put it on the ground and expect it to fly straight up. The rocket first needs to gain speed so the fins can effectively stabilize it. And that's why rockets without active control, like gimbaled motors, are often launched from a rail. And if my calculations were right, this 2-meter steel rod should be enough. The next day was launch day. We walked to the middle of a field, which was probably a bit confusing for people who saw 4 guys carrying a rocket and 2-meter steel rod. I set everything up, took off with my new DJI drone that I had just bought and connected the igniters to the rocket, while laying on the ground for some reason. And after that, everything was ready.
3, 2, 1!
Yeah, that really wasn't supposed to happen. The rocket didn't fly straight at all, the SD card flew out, the body broke, and the parachute deployed, but already on the ground. So basically, the entire launch was a failure. But that's part of the process, and I don't give up that easily. So after I got home, I wanted to fix all the issues and give it a second try. First I thought about why it didn't fly straight. This usually happens when the center of gravity is too close to the center of pressure, which is near the fins. So I moved the flight computer closer to the top and added a small weight to the nose cone. For the SD card, a piece of tape was enough. But what about the parachute? The reason it deployed on the ground was it didn't have enough time because the rocket stayed too low. Moving the center of gravity should fix that. And I also 3D printed a small shield that goes between the parachute and the charge to protect it from heat. Then I glued the broken body back together and it was ready for launch. And just when everything was finally fixed, the weather became the final boss. We set everything up and tried to launch it. I pressed A. Nothing. Again, nothing. And then I realized the launcher was completely covered in snow, and I didn't really think about the fact that snow is conductive. As if it wasn't enough, my GoPro shut down because of the cold, my drone battery was low, and my fingers were freezing because I forgot my gloves. So since everything failed before the launch even started, we packed everything up and went home again. The next day looked better. And since rain was expected for the next 5 days, it was now or never. After walking to the field for the third time and setting everything up, it was time to try one last launch. I installed the igniters, moved away and pressed A.
3, 2, 1.
After all the failures, it finally worked. And honestly, that moment made the whole month of building it worth it. The rocket flew straight up, separated almost perfectly, and for the first time everything went according to plan. When I got home, I analyzed the data from the onboard computer. The maximum speed was 68 meters per second, and the maximum altitude was 288 meters. The onboard footage also looks great, and the GoPro did a good job. The parachute didn't fully deploy though. This was probably because the cord that was supposed to pull the parachute out and then break snapped too early. But even with the partially deployed parachute and the drag from the body itself, the rocket survived without any damage. I'm also really glad the flight computer worked, because that was honestly the hardest part of this rocket. I could have bought a better one, but that would cost over 100 euros, and I built this one using just an Arduino and a few sensors for about 25 euros. If you haven't seen the build video yet, you should definitely check it out. I covered the entire process there and many things I didn't even mention here. And this is definitely not the last rocket video on this channel. I still have a few motors left and a lot of ideas. So if you want to see more rockets, rocket motors on a bike, or even a guided rocket, please consider subscribing. Your support makes these crazy projects possible. If this video wasn't enough for you and you want to see all the details, in the description are links to 3D models, documentation, etc. Thank you for watching and see you next time.